Hello there, everyone. Welcome to Techies Forum, and I hope you people are excited for our session on getting started with containers and orchestrators, part one. So, as you know, this is a two-part series. So, this is the first part in which Vivek is going to tell us all about orchestrators, containers, and how you can build applications using that. So, let's welcome the speaker for the session, Vivek Sridhar. Hi, Vivek. Hope you're doing well.
I'm alive, by the way.
Yeah, yes, you are.
Okay, I was thinking I'm still in backstage.
Yeah, we are live in the.
Hey, Ashiva.
Yes, Vivek.
Yeah.
So
Hey, Ashiva. Yeah, thanks, man. Thanks for inviting me for delivering this talk to Bhubaneswar developers. I mean, I'm pretty excited to deliver this talk today.
it's a pleasure to have you on board, Vivek. So let's get started with your session, and I'm really excited and looking forward to it.
Cool.
Okay,
Okay.
it's all
So
yours.
thank you, Ashwad. So, when Ashwad reached out to me and asked me how we can do containers and Kubernetes session to the Utkal Techie Forum, I said, in one session we cannot have this. Let us break this into two sessions, and then we thought of making sure that this session is broken down into two-part series, and one is which is today. We're going to talk about what is containers and see how you can Dockerize a simple Java app, and we will deploy container in the cloud. And it's basically today we will focus everything and all our energy onto the containers and understand how to get started with containers. And I think the next session, which is on 28th Feb, I believe, we will focus on Kubernetes architecture, its terminology and concepts, and try and see how to deploy a multi-container, and obviously everything with a demo. And today's session, I will have very minimum slides and more of a demo, more of hands-on, so that we all learn the containers and how to work with containers. Okay. Before I deep dive, I just want to introduce myself to the community. I started my career way back in 2006 as a software developer at IBM, and you know, I just had a passion to be a DevOps guy, and I liked production management, and I enjoyed building the DevOps automations and using a lot of tool sets of DevOps. So I joined HCL as an architect, and I was also head of DevOps at the BlackBuck. And then I had my own company, and I worked with DigitalOcean as a senior developer advocate, working with various startups and communities. And today I'm with Microsoft, taking the developer tools to the developers and working with a lot of developers across India. Given my introduction, we will see why we are talking about containers and orchestrators today. It's very important to understand because if you see this slide, by 2022 we will have almost all productions, like 75% of global production will be running with containers, and it definitely requires an orchestrator to manage these containers. So it's very important for the for the community, for the developers to understand how these containers behave and what are the tool sets which are available to work with these containers, and how to manage these containers in production, and how to take these containers to large scale applications and to scaled applications, right? So given that, let's see what is a container is. Right. So I'll give you an example. Right? I mean, way back while I was working in startups and in enterprise environment, the way we used to develop code was developer used to sit and have his own set of environment for him to develop things. So he would, install his own binaries and libraries to write the code, and then used to send that code to the operators or system operators, um, or the DevOps engineers, and then they used to package that code, and then they used to ship the code to the production. Now, what is the challenge there is that, this the code which is there on the libraries or the binaries which is there on the developers environment, right, is quite different from the environment which is there at the production. So there used to be a difference. And developers, while developing, they used to install various things, and they have their own way of developing. So they install stuff, and they forget to package it, or send that information across. And since, any large team, right, if there are 50 developers, it's very difficult to manage these kind of interactions and conversations. And it obviously slows down the way the code is shipped, right? And that is the challenge. And the other thing is, the same, and it was very difficult for a developer to create his own environment for driving a code in the production, right? I mean, if there is something broken at the production side, if I have to have the same environment for me to test it and to fix the issues, there are some challenges, because I need to set it up for myself, right? And which is again, needs to have a separate kind of activities, or need to have someone develop all those things. And then there is a challenge in terms of reusability of these binaries, right? And if I install JDK8 on my production environment, and if I want to use other JDKs from a Java perspective, or in a Python version, if you see, that I might be using 2.7, there is 3, I need to have different set of Pythons for different activities which I'm doing, or different kind of code which I'm running. So there is a challenges, right? There is, because on the same machine, if I'm having these different binaries and libraries set up, then it was really difficult to run it in the production. And something fails on one of the binary fails, or one of the library, there are some issues, the other code used to get hampered. So the apps were not independent, it was dependent on each other. So this is similar, if you take from the virtual machine, right? I mean, if you see the slide, virtualization is more from your VMs are the unit of scaling. So you are specifically scaling your VMs. But in a container system or a container environment, it is always about packaging the application, right? So what is container? It's nothing but a packaging your code with all the necessary binary, all the necessary uh, configurations and dependencies. You're packaging it together, and you're hosting that package, the same package in production, in developer environment, in QA environment, or any other environments you have. So that's the crux of it. So what it gives you is the flexibility of porting your code from one environment to another environment. For example, you're running a container in on one of the virtual boxes, and something happens to virtual box, you can easily pick up that another container, or you can kickstart the container in another box. It's very easy, which is not the similar case if you had a traditional development style. So what we used to have was a problem we used to have was getting from developer to production. There was a time consuming process, because the environments are different, and we need to test a lot and other things. And then there was low utilization of resources as well, because of since we were not packaging it together with all the necessary configurations, and with the dependencies, there were some issues with running these containers. And obviously, the portability was one of the biggest challenge, because I need to port these applications in various virtual boxes, and it is always dependent on the virtual box where it is pinned up. And if there is a new virtual box which is coming up, I need to have similar set of configurations and dependencies installed before I run my applications in a traditional way, right? And it always used to be a challenge. So in a containerized world, it's pretty easy. So it is very lightweight, and you can easily scale because these are all packaged as a similar way. And once packaged, you can reuse it and you can port it. You can, even the developers on different boxes, they can install it, and migration is easy. And also it's obviously, as I told you, it's the resource utilization of resources are better. And if you see, it is all running on a Docker engine. If you see from the slide, and the difference between this slide and this slide, uh, there is a hardware, there is host, and then there is hypervisor in the virtual box, and then there is virtual machine, and then on top of these, there is containers running. You can obviously, in a cloud world, you can have hypervisor and virtual box, and then Docker engine on these boxes, so that the containers can run with the Docker engine, and create its own set of the application can create its own set of necessary dependencies and configurations package, and then run it together. So um, I don't want to go deep into the benefits. It's already given that it's very fast to ship apps if you have containers, and if you have containerized your application, and it is easier to port, and it is efficient. You're also, efficient from the resource management perspective, and obviously scale is something which is very important, and we will see that how these containers can scale in my next session, which is on Kubernetes. But this is very important. The applications which has been built has to be built for scale, and it has to scale the way it has been built, right? And it's not like you do so much of work to scale it. It is more from, is there a way or a tool which can help you to scale? So we will see that in the next session as well. So I'll just deep dive into demos because it's more important. We'll see so many demos and so many activities now. We'll go through one by one. Let me end this, go back to, and let me talk about most important thing. So Docker is a container. It's a tool for the container to run containers. Container is a concept, and Docker is a platform and a tool where you can run the containers and build the containers and execute containers. So basically, the way it is structured, right? It is always called as all the things you package. You can package it with a Docker file. Okay, so Docker file is nothing but configurations. Okay, and it's basically a configurations or the steps which is required to build a image. So everything in Docker or in container world, it's called images. And what is an image? It's nothing but a package. So I did talk about the package, right? And we will see that a set of commands which is there in the Docker file, you will create an image out of it, right? And you'll package it. And this you used to do, and it is an artifact, right? You have to create an artifact to use it in different environments. So it's a very simple way. And if you're from DevOps background, or if you know how to deploy an applications in cloud with from a DevOps perspective or from a production perspective, you would understand this as you had a package, you had steps to package, and you package it into images. And once you package it into images, what you will do, you have to store it in one of the places so that everybody can access it, right? Where do you store it? So that is called as container registries. uh, okay, just container registry. And then you have the uh, you know after putting that image in the container registry, what developer 1, developer 2, and developer 3 can do. Developer 1 can pull this image and execute that image, right? Developer 2 can pull this image, and developer 3 can pull this image. So what does image has, it is a package already been created. It's a pre-built package, and he can pull that image and run on his laptop, and the same thing can be run on the production. Okay, and with the pull. Now, how did the image got into container registry? So as a developer, I build the configuration file, and I edit those configuration file, and I create the image. And once I create the image, I want to use something called as push. So it's very simple. It's like your GitHub. How do you use push, GitHub push, and GitHub clone, and all those things? It's the same. So you're pushing the image to a location, and which is a shared location. And container registry as well comes in very different way. One, it can have a private registry, and um, you know uh, registries, private registry, and it can have public registry. It can have or it is on the Docker Hub. I'm talking about public cloud registry, and then there can be Docker Hub. When I say private registry, you can set up your own registry for your containers in a private network, on any of the boxes, virtual boxes, or in a different place, or you can have it on a public cloud, and or on a Docker Hub. And there are a lot of pre-built images already, and I'm going to show that as well. So this is a simple way. Configuration file. I create configuration files. I go back and create an image on my local system, and I create and I push that into any of the strategies I have for maintaining my artifacts, and I'm going to push that out. And then other developers can pull that onto their laptops, and even for production, it can be pulled from the same registry where this artifact is being stored. Okay, so given this, I'll just show you, Docker Hub. Docker Hub is nothing but, as I told you, it's a place where you can host your images, and this there are pre-built images. There is, you can see here, there is so many container images which is already there, which is official images are there. There are a lot of other images for testing and other purposes, so you can easily get these images, install these images, and start running it. So this is a very interesting way to use the images. And obviously there is already pre-built, so you don't really have to go back and build all these images. You can directly use these images and run your applications. Okay, so there, this is a Docker Hub registry, and the way I have been using is the public cloud registry. Microsoft Azure provides me a public the uh, container registries, but I have already created it, so that we don't spend time in creating it, but I'll show you how you can create it. So just go here, into this, and click on create resource. Okay, so it's very easy to create. Just click on create resource, and type in container registry, and you will see container registry, and you just click on create, and that's it. Provide your resource group, provide a name, and oh, um, Vivek test 001. It will make sure that registry is available here with vivectest.azure.cr.io, and you choose the SKU, and then networking, whatever, and then just go and create. So it will get created. So I've already created. I don't want to spend time while it is getting created. So not just that, all resource. Let me go to my container registry. I already have a registry here, and this is the URL for that registry. I already have an image which I have already built the version one of the image into this. I've already put a version of my image here. So I'll show you how I can go. I'll be accessing this, and I'll be using different set of things. Okay. Um, Before we go there, right? So let us go back to my code. This is a code which is just a simple Java code, and it is just giving me I'm just trying to do a today's date, and saying, hi developers, this is JDK8. So why I'm going to use JDK8? There are two things which I'm going to show you: how you can build a package with different dependencies and configurations, and use it on the same laptop, run it on the same laptop without having any issues with your system, right? So let us go back. So if you see this, these are this is my code. And when I explain to you, the next step is obviously the configurations to build a Docker file. I have the code, but I need to have a Docker file to run it. So I have a Docker file which is built with certain commands. So I just want to explain what are those popular commands to build a Docker file. So there are a couple of commands, right? And when I talk about these commands, is more important is from command. From is nothing but a base, from base of the how you're going to define, and what if from which you are writing this particular Docker file. So that means it can be from Ubuntu, the base of your code which is supposed to run. It is going to run on Ubuntu, or you're going to run it on different image. By default it is CoreOS, and there is Linux is what the by default it is if you don't give anything. And you can actually you know give the way you can define it. So if you see this, there are three ways you can do it. From a from perspective, it can be a base image, or base image with a tag, or base image with the image digest number. So if you see, I have given the base image with a tag which is 8, tagged as 8, and we will see how exactly it executes later. But if I go into commands like from, you can start with the base OS, or you can tell from where to start it. Start the Docker file from where the base image has to start, from where this image building has to start, and you can actually provide that from environment. An environment variable is very simple. You can easily understand from the code I have typed here, right? Environment is nothing but a port number which is there. So you are going to use that port number, or you can define any of these environments which you're going to use. So working directory is very simple. This is where the context. So anything you execute in the Docker file, this is where you are setting a context. This is the place where you're going to run certain things. So you can say this is the working directory, and then all the commands under that will be executed in that working directory. So that is the meaning of a uh, working directory command in Docker file. And there is something called as entry point. Entry point is nothing but the executable for the container. So for example, you package package the image, and you want to, when you run this image as a container, when you run it, something has to be executed. So that is where this entry point comes into play. And command is nothing but you're setting some of the commands in the Docker, and only so not some of the commands. You can only run one command in the Docker files. If you go back here and point it out to command, there's only one command which you can run. And entry point is more from executing it, and command is more from either one command get executed before setting up something, and then what you're doing is, it's not just command running a command there. It is also you can make a change to this command while running your uh, Docker while running your Docker file. So while not Docker image. So this command can be executed while you're running it, starting the your Docker, or either you can set it in the Docker file itself. And copy is nothing but you're copying from local file system to the source, the path where inside the image or inside the container, right, while it is running. And add is very simple. If you have a zip file, you can unzip it directly in the container, or if you have something to download from a URL, it will download into that location which has been provided in the add. And then there is run. There is a command where it is just you are running some commands, and expose is exposing a particular port. Say if you want to you did set an environment, it's HTTP port 9000, and you executed a say Python Flask or any of those application and execute it on top of this, and then 9000 will be exposed, so that from external I can access it. Apart from these, in order to containers, you need to have a connect between two containers. That is where you can create a network and a bridge, create a network bridge, so that you can connect two containers. So let me go back. So this is a basic of how you can write containers, how you can design a Docker file. And I'll come back to this while we are doing. It's very simple. I'm just giving from OpenJDK. I'm just taking the tag of 8 and copying my local source code into this location within the image I'm creating. That means when I run a container, the code which is there, or the code which is was there already, will be packaged in this location while building it. And then my working directory will be this. It will enable this as a working directory because I copied my package there. And then I did run compile for Java, and then there is an entry point, right? And so entry point is nothing but this is the command which you're supposed to run whenever I run this specific container. So that's the design of it. I covered most of the Docker command here, and this is a code which is running, and I just say from Java JDK 8, and then I'm running it with uh, you know we are in this location now. We have a Docker file, and we have supposed to create an image now, and then push it, right? So let us go back to my CLI. So I just want to show you a couple of things. So once I install Docker on my local system, I have done the development. I have done with my Docker file. It is ready, and I need to run a couple of commands to make sure that this particular Docker file is built, right? And so if I click, if I run Docker, I'll get all the commands which is listed. So the the most important thing is to understand all these commands, and I will not be going through all the commands, but if you need to learn these commands to build a very familiarity with some of these commands which are really required to run a Docker or an image. Let us go back, and I'll show you a couple of things. So Docker images is a very simple command. It will show you all the images which is already there, and you can see that I have OpenJDK 8 which is tagged, and then there is OpenJDK which is latest, and I'll talk about latest when I do a demo of it. But just imagine, I've the reason why I've already installed OpenJDK and I've already downloaded that image is because it takes some time. So I just want to, because if you see the size, it's a couple of, it takes some time to do over a network, right? So so let me show you a couple of other commands. I did talk about network. Let us click on that and see there are a couple of commands which is there. So let me show you the network is to connect between two containers, external containers to talk to each other. You're running two containers and you need a network to talk to. So you need to create a bridge out of these things, right? So what I'm doing now is I'm just putting the Docker, ls, and I can, sorry, this Docker network ls. So you can actually see there is list of already created bridges which is already there, and you can actually go back and create yes, yeah, a new network bridge I created, and I can use this bridge for connecting two different containers. So I can just go back and click on this, and you can actually see this, right? So we did create a new bridge. So let us go back and see a couple of commands. So I have images, and if I click on ls, I have Dockerfile, and also code there, and I just want to build this Dockerfile now. The command is to build, and Docker has a command build. So if I click on this, there is help, which we can see, build help, and you can see there's bunch of things which you can do with while building. So there are various things you can actually go through each one of these, but a simple way to build it is Docker build -t my app jdk 8 version 2. So why I'm calling it as version 2? Because I have my version 1 in the registry already. I did show you how to create a container registry, which is a repository, right? And in that repository, I already have a version 1, which we will see how to pull it and run it here. So this is version 2, and I'm giving a dot here because I want to pick up the Docker file from the location where it is. So now it is using OpenJDK 8 version. You can see this because I've already installed the JDK, or already have an image of JDK on my local system. It doesn't require it to you know doesn't require it to download it, and it does one by one from JDK copy work directory, and then it runs the command the compiler of Java, and then enter point, and it successfully builds it and tags it as a version 2. Now what happens here? So I go back to the command images, so I can see my version 2 app is built, and it got 30 seconds ago it was built, and you can see PS it's not running because we didn't run it. And I'll just say run, and the beauty of Docker is I can just give first three first three letters of the image ID, and I can run it. So when I say Docker run something like this, it did say hi developers, this is JDK 8, correct? Cool. So this is JDK 8. We built it on locally. We have it locally ready. So what is the step we need to do? So let me go back here. So we had container registry done here, and it was on the public. Sorry, I missed this. We did it on public cloud, which is Azure, and we don't need this. We don't need this. So we have image built. This is done, and we have image built, which is done. And now we need to push that image, so which is good to push it. So let me go here and open the Docker. So now you can see this is my local. This is the one which I built it, and this is OpenJDK, which is already there on my machine, and this is the one which I built it. So now what I have done is I've installed the extension to use locally the container service, and I've connected my public cloud to it, and I have the registry which I have built. So this was the registry which I had built. So if you see this, this is my registry name, and this is app which is there on the registry, and you can see this. So both of them are here, and I'll just go back to my Visual Studio. So you can see this registry is here, and my app is there, version 1 is there. I have it ready, right? So let me restart this, and it's there. Okay, and this is my local system. Now what I want to do is I want to push this version 2 into my cloud registry. So what I'll do is I'm going to select the registry where I want it. So I'm going to select the registry, and it will show up, and I'll just say enter, and it will start logging into my public cloud and from a Visual Studio, and it is pushing my container to public cloud registry, and it is just pushing it because I already have image there, and it's easier and it's faster to push it. So it will take some time. Got it. So it's getting pushed and it's done, and this will be terminated if I click on. Okay, now it is terminated. So now you can see here, I'll go back and refresh this. I can see there's a app 8 has been pushed. One was my app, and the other was the something else which I built right now, and it is the code changes were there, and I have added it. So it's a version 2, right? And it's version 2 and it's version 1. I can, if I had used the same name while building it and had given version 2 as a tag, it would have been under this specific container, which is specific image, in fact. So the difference between an image and a container is image is a package and it is ready to use, but container is running containers. You can run the containers. Okay, so there is a difference between both of them. And if I have to download my version 1 to my local, I just click here and say pull images. So I'll just say pull, and as if I click on pull, it will just go and pull image into my local desktop. Right, it is pulling the image, which is my first version, and you can see it is already getting pulled. Okay, now you can see here it is getting added. So this is my containers. I'll just show you images. So now I have bunch of images ready. One, I have JDK 8 version 2, which I created an app with JDK 8, and then I pushed it. So it still creates a local copy of it before pushing. So it's still, if you can see this, both of them have the same image IDs. And then now I pulled a new one, which is version 1 with a different image ID, which is a separate from this. It's a version 1 basically. So if I have to run this, docker run 0cc, you can see the code itself is different and the output is different, right? So you can see that I just pulled this image. I didn't do anything. See, I didn't install JDK 8. I didn't do anything. I didn't have that copy of code and I copied it or something. No. So I just, did a pull. I just run it, and it is the same thing which can be run on production as well. So all the dependency was here was JDK 8, right? Now we're going to go back and go to my code, and we will change this to latest. And I can give latest. That means whatever latest OpenJDK available on the Docker hub, just pull that and create an image for that. Okay. Now what I'll do is images, Now I have the Docker file added, new one, right? New latest JDK 8. So let me go back, and what do? I'll go click Docker. I'll just run Docker and build to which one tag. So with what tag? My Java app JDK latest dot. So I'm building it. So if you see, there is here, it's OpenJDK latest when I build it, and then the remainings are the same. It is tagging here, and you can see Docker images. Let me run it here. Okay, so now um, I have built a my Java app with a tag JDK latest, and you can see that's a completely different thing. And what I'm going to do now is, if I go back and say docker run, but we didn't change the code, that's really bad, right? Okay, anyways, that's fine. I can just go and run 3f4, and you can see there is a code, but we didn't change it. This is a JDK, latest. That's fine. So we can still build it again if you want to. Let us do that just for our understanding. Okay, Docker ps -a. I have so many things running. Docker remove. Cool. So Docker images, Docker images. I have these Docker ps -a. There is nothing running. Docker ps, nothing running. So now we can remove image which we created. Let me remove that. Okay, now I've removed the image which we created. So now if I go and say image, there isn't JDK 8, but there is no latest, right? So cool. So nothing is there. So let's go back to my code and say this is JDK latest. Okay, now there is change in the code, and this is Docker file with latest, and there's a change in the code, and we're going back to my terminal, and we are going to build with the tag my Java app JDK latest dot. Okay. This is my local. It is getting built and tagged. Simple. And we are going to go back and see this. And now we have JDK 8, sorry, JDK latest, which has been tagged and it is ready. Now if I run 9f2, you can see there is a change in the code. The image is changed, but it is in the same name of this image name, and it is a different version, right? And we go back, and what we do, we go back here and we see the JDK latest is here. We push it to my system, my registry, in fact. So if you see this, right, I mean, I just changed the different JDKs, and now I'm running different JDKs. This is the way you can package it with different set of dependency, right, for this application. And there is a completely different library or a binary which we are using. We can obviously create a package with the different configuration, which are different, different things, and then run it on the same box. I can run both the containers on the same box without affecting each other. And there will be no dependency, there will be no issues in running, if something happening to one app and the other app is getting affected. So that is the main advantage of uh, the having the containerized strategy. So it is getting pushed. Let's wait for some time. It might take some time to push. Pushing. Almost done. Okay, while it pushes, um, let me come back here and show you all my system container registry which is there. I have repository already, and in that repository I have different applications there, and my Java app has two versions. You can see already one is two tags, in fact, so which is nothing but a version. One is version 1, one is JDK latest, which we just built it and posted there, right? Now what I'll do is I'll go back and run this particular thing in the cloud. Till now we were running it on our local system, and I want to run this specific thing in the cloud. So how do I do that? Container instance. I'm going to create a container instance with same resource group and name it as container test. And then I'll say Azure Container Registry. So it says admin user must be enabled first, and oh, I didn't enable the region or access the image. Okay, I did mistake there. Okay, let me go back to my resource. I need to enable it. So I'll go back here. Where do I enable this? Access key. Enable. Successfully enabled. Okay. I hope I have. Now, again, I go back to container instance, book create in container instance. I'm going to select the same container registry, container test, Azure registry. I have registry already. I can select whichever app I want. I'll say this app, which has a tag of JDK latest, and then I can choose the size, whichever size I want to, and you can say whichever size you want to for running this particular container. And you can talk about the network or the access to it and other things which are a little bit of advanced, and what command to override. This is how you can write the CMD command, right? You can override while this container runs whichever is there inside the container. So that is the reason why they say you can have only one CMD command within the into the Docker file, so that you can override it whenever you're running the command. So review it, and then we just go back. When it is validated, we'll just run this. Okay, so when I run this, it will just submit it, and it will create a deployment. And once it is deployed, it will take some time to deploy. So while it is deploying, it has got already pushed, and you can see this. Now we did have version 2 things. So let it get deployed. Give me some time to deploy this. So while it is deploying, we can actually go back and see my resources, and I can see this. So this is my repository, which is there. Oh, we already saw this, right? So there are a couple of things you can do. Now you can see check logs and other things on these registry logs, in fact. So let me go back to the deployment, which we actually have to see. So go to my resource. So you can see this is where it is running. Containers. So this is the container. Status is running. And you can see the log, and it is run, right? And it is like, hi, dedicated. So it has run the code and which we had to run. So it's easy. So just you can go here and this container instance, you can restart, stop, and run it, because I had the settings done like stop it whenever it is not running. It was not, so I can stop it, stop the container which was running. I can stop it and then start it again, and you start it again, it gets started. That's it. So it's easy. So what we did was we went, let me go back to the discussion which we had, right? We created a Docker file, we created code. In fact, before this, we had a code for doing some kind of application development, and then we had Docker file created with some commands listed out there, and you configured it properly, and then you created the image on the local system using Docker create and build image command, and then you did push it to the container registry. So when you had a container registry already set up, it can be set up in various places. So one we choose was the Azure platform, and you push that into the Azure platform, and I was able to pull it and run it on my system. I had pulled the version 1, which I had already posted on the public cloud container registry. But it was, anyways, the same way you are going to use it in the development as well. So you're just building it and pushing it out there so that you can easily manage these things. So coming back to my slides. Um Cool. So we did see a lot of things. I know there were so many things which we covered. So this is one thing which I just wanted to show to the community as well. We have a newsletter where we usually have a lot of content on various such latest topics, and also wherever these kind of sessions are happening is all listed out there, so that you can join and learn and upskill yourself. And there is, it's not just about joining this newsletter. You can also contribute. If you have an amazing blogs which you have written, just reach out to me, and you know send me those blogs. If it is really good, I can nominate it to be part of the newsletter. So I just want the community to go back and build these learn these technologies, and not just learn it, but also go back and share this content with the rest of the community. So given that, I'll just close this session, but I just am happy to take questions if there are.
That was an amazing session, Vivek. So let's see for some questions. I request the audience to ask any question that they have related to containers or architectures. orchestrators. I'm sorry.
Is there any
That's
question?
not yet. I'm just looking in the chat section. In the meanwhile, we have any question, Vivek? I have a question for you. So, we are making so many instances and so many container images. How do we manage that? Isn't it cumbersome? And don't we blow out a simple application by containerizing it? Like you have to maintain so many things right now, and you're not aware what the other team is doing. It can make chaos.
Yep. So basically, you can actually build those. I mean, obviously, orchestrator is supposed to be the way forward to manage these containers. In fact, you just need to copy these. I mean, these containers has to be built in a way to run it in the orchestrator like Kubernetes, because that's the way to manage these containers from on a scale perspective. Obviously, single containers won't help, so that is something which uh, you can easily manage it, by the way. And I
Okay.
see there is a question saying how do you manage your tags. That's the similar way we manage it in the GitHub, right? So everything is managed in the GitHub, and you need to have a process to manage these tags. The way you want to, you know it's kind of a process management. It's not even a technology, it's kind of a process management. And same way, the way we manage it in the uh, you know in the GitHub, right?
I hope it answers Sabrina. So thank you. There's one more thing, Vivek. Containers has been in the buzz since last 2 odd years, 2 or 3 years. Maybe it's more than that, but I've been hearing this since last 2 3 years. So when we make an application, there can be a different type of application. There are n number of applications in which we can build. So what kind of application do fit in to be containerized? Like every application can be containerized, but what sort of applications should we actually move to containers instead of doing it in the usual way we do?
So, see, the modern applications are definitely part of it, and the applications which you need to ship is very important, right? The shipping the applications which is fast. You need a fast paced shipping, is where it is required. But traditional applications is also something people are looking into as well, right? Because uh, as I told you, there were so many issues, and there are so many issues in managing the portability, the managing the bringing developers close enough to the production environment. Those things are always there even in traditional environment. So as the world progresses, the the first slide of mine is talking about we will have everything containerized. At least from 5 years from now, everything will be a simple containers will be running. And uh, and and the more the code is broken down into smaller pieces, right, to be managed easily. That is where the whole container ecosystem will be helpful as well. So I would suggest everything, you know either enterprises are moving towards the containerized world, and startups and various other modern applications is already in this journey, and they started with this journey. In fact, most of them have started with this journey, and futuristically people would go directly into this, and that is the whole crux of it.
That makes sense. So we have one more question from Harendra. So it's like, how can we achieve this using Azure DevOps CI/CD pipelines?
Yeah, I mean, you can just um, I mean, it's in DevOps, it's all about all these things and running stuff, right? So it's a good question. We can. I have a session next week, which where I'm doing, the DevOps pipeline, CI/CD pipeline. Maybe For your help, I can run the containers in that. I don't have a plan to run a container, but I will definitely try and include a container in that and explain it to the community for you as well. So if you can make it to that event, that will be helpful. I'm doing a live demo of Azure DevOps itself.
So Harinder, I hope you stay tuned for the next session in which Vivek is going to answer that by giving a demo. So I'd like to thank Sabrina and Harinder to, for asking the questions. And Vivek, would you like to add up, where people can just get started and, some resources which they can refer to get started with containers?
Yes, I mean, I would suggest to go and try Play with Docker. There is a website called Play with Docker, and you can actually learn all these commands. And there are a couple of, nice blogs in terms of command line cheat sheets. You can actually go and understand these commands better, because there is so much in the command line you can do. As I showed you, there were so many commands, and I used a couple of commands, and even Docker run has so many options, right? I just used Docker run as a simple command, but it has a lot of options, and it is good to go back there and play with Docker as a to run all these commands and see what it does and how it does, and use all those shortcuts which is there, and it will help you. That's something which people can take it forward.
That was really helpful. So let's wait a minute and let's see if we have some more questions. If we don't, then we're good to close the session.
I don't think so. Anything coming in?
So let's call it a wrap.
Yep.
Thank you, people, for joining in on a weekend. It was really helpful, and Harinder is saying thanks. Same with Sabrina. Thank you so much. Thanks, Sabrina. We are glad that you like it. I hope you people stay tuned for the next session of Vivek, in which he talked more into orchestrations, right? Vivek, would you like to add up something about your next session?
It's more about orchestration. So Kubernetes. So it's more. It will completely take you to a different world. If you're from a traditional background, the terminologies, the concepts, the language we are going to talk about there, everything changes. So it's very interesting session, and it will have demo. It will have all these. We will go back and build such simple application, push a simple application into the Kubernetes, and we'll bring it up, and we will go in depth with the object model. So YAML, how to write that YAML file for building your pushing your application into Kubernetes. So very important aspect of high level programming language. It's not a language, it's kind of a high level programming, I could call, from a YAML designing perspective for Kubernetes. So we will see that in my next session.
That's super exciting. So there's a lot many things jammed up in the next session. So looking forward to that. Thank you, people, for joining in. I hope Vivek, you'll be sharing the slides and the code later.
Yeah, I mean, I can share the slides. Code is already there in my video, so people can pick it up. I mean, it's a simple Java code. It's very simple.
Truly.
Yeah.
Okay, so that's a wrap. Thank you, people, for joining in. Have a good day, stay safe, and do tune in for our next session on February 28th, same time, same channel. Till
Okay.
then.